Good morning, all. Today we will discuss some of the examples of resolution. We have already discussed resolution in the previous sessions. So we have seen the steps for resolution. So here we will explain with an example. So initially we have a set of facts. Here these are the facts given. We can go through it. Marcus was a man. Marcus was a Pompeian. All Pompeians were Romans. Caesar was a ruler. All Pompeians were either loyal to Caesar or hated him. Everyone is loyal to someone. People only try to assassinate rulers they are not loyal to. Marcus tries to assassinate Caesar. So the first step of resolution is we have to convert it into WFR. What is the need of it actually? So we know that the computer and the AI does not understand the natural language. So uh, they does not understand English directly. So we convert the sentence into first order logic. So for that we are converting this into WFF. So we will see how we can convert. So Marcus was a man. So there Marcus is the subject and the property is being a man. So we can put man Marcus. Marcus was a Pompeian, similar to the first one, Pompeian Marcus. All Pompeians were Romans. There we use all. All means we have to use universal quantifier. So for all x and x is a Pompeian. So Pompeian x means that he is a Roman. So Roman x. So if someone is Pompeian, then that person must be Roman. Then Caesar was a ruler. It is similar to first two sentence. Here you can see ruler Caesar. Then all Pompeians were either loyal to Caesar or hated him. So for all Pompeians, we will represent using universal quantifier for all x Pompeian of x. That implies, here you can see loyal to Caesar or hated him. So we can put loyal to x comma Caesar. X is x comma Caesar. There is a or is there. So we can put or symbol hate x comma Caesar. Then everyone is loyal to someone. So we have to represent everyone using universal quantifier for all x. To represent someone, there is existential quantifier, that is some y. Then loyal to, so loyal to x comma. And then people only try to assassinate rulers they are not loyal to. So here for representing people, we are putting for all x, person x. And there is one more subject, that is rulers. So we can put rulers y. So rulers y, for all y, rulers y, and person x and ruler y, and try to assassinate x comma y. X is trying to assassinate y means what is the meaning? Then not loyal to x comma y. Then Marcus tried to assassinate Caesar. Tried to assassinate Marcus comma Caesar. Then here we can see man Marcus is there, and here we have used person x. We know that person and man are same, so we can write it as a additional WFF. So here I am writing for all x, man x implies person x. Next, second step of resolution is we have to convert it into closed form. So the first one, man Marcus, there is no change. Pompeian Marcus also there is no need to change anything. And the third one, all Pompeians were Romans. So we get how we can convert into closed form. So we will see. For all x, P implies Q means there is a rule we already discussed. If it is a P implies Q, then we can convert it into, how we will convert? We will convert it into uh, not P. So we will convert into not P or Q. So similar to here, you can see here not P, that is Pompeian of x or Roman of x. Then what is the next step? So that is first one is, yeah, remove the implication. Then second step is we have to remove this all x. So only I will explain the required rules only I will explain here. Remaining rules we are not applying, so there is no provision to applying the remaining rules. So then we can drop this universal quantifier. So this clause will become not Pompeian of x or Roman x. Then next, ruler Caesar, there is no change. Then next is for all x, Pompeian of x implies loyal to x comma Caesar or hate x comma Caesar. So here also we can apply the rules. Here it is similar to P implies Q. So we can apply not P or Q. So here you can see for all x, not component of x, or that is P or then Q we are writing. This is Q. So we can write loyal to x comma Caesar or hate x comma Caesar. Then here also one more rule, that is we can drop this all x, we can remove it, so it will become not component of x or loyal to x comma Caesar or hate x comma Caesar. Next sentence, that is for all x some y loyal to x comma y. So here it is actually it is x comma y. Then here we can use the column function. We can convert this y into f of x. This is the column function. F of x is a column function. So this will and then we can remove this all x and some y we can remove. So it will become loyal to x comma f of x. Then next for all x all y. So instead of person x, I am putting man x because we have a one clause we already discussed. Person x and man x both are same. And ruler y, try to assassinate x comma y implies not loyal to x comma Caesar. First we have to apply P implies Q. So here you can see not P. So not P means not man x and ruler y and try to assassinate x comma y all in bracket, and then or not loyal to x comma y. This is similar to not P or Q. And then you can see we have to take this negative inward. So this will become a negation of man x and not ruler y, and this or and will become or, and here also this and will become or and not try to assassinate. The remaining part we can add or not loyal to x comma y. Then the next one is try to assassinate Marcus comma Caesar. There is no change in that. So that step is completed. That is, we converted all WFF into closed form. Next, we have the question. Here we can see. Here we want to prove Marcus hates Caesar. So, so we first. So this is our goal. We have to prove Marcus hates Caesar. So in the resolution, what we will do is we will take the negation of the goal. So here our final clause is actually hates Marcus comma Caesar. So we are taking the negation of hate Marcus comma Caesar. So we are taking not hate Marcus comma Caesar. This clause is added to the set of clause and the resolution algorithm is applied. So we will see how we can solve this. So we will see the resolution graph. So here we are starting with the negation of our goal state, that is not hate Marcus comma Caesar. We will check with our clause whether it matches with any of the clause. So here we can see that we will go through each clause one by one, and there is a fifth clause. There you can see here we have not hate Marcus comma Caesar, and here we have hate x comma Caesar. So if we apply unification, then we can solve it. So here we are applying unification, that is we will substitute Marcus as x. So then this is matching, and these are hate x Marcus comma Caesar. Here they are complementary clauses, so they will cancel. So we will take the remaining thing, that is not Pompeian x or loyal to x comma Caesar. Here x is Marcus, so it will become not Pompeian Marcus or loyal to Marcus comma Caesar. Then we will check whether there is any matching with any other clause. Here you can see when we are taking the second one, Pompeian Marcus and not Pompeian Marcus. So they are complementary clause, so they will cancel. So we will take the remaining thing, that is loyal to Marcus comma Caesar. Then we will check the matching. So here we can see that loyal to Marcus comma Caesar. So loyal to Marcus comma Caesar is coming in the seventh one. You can see here not man of x, ruler y, or try to assassinate x comma y, or not loyal to x comma y. So if here also we can apply the unification algorithm. If we apply the unification algorithm, unify Marcus as X and Caesar as Y, then these are matching. Here you can see loyal to X comma Y and loyal to Marcus comma Caesar are complementary and they will cancel. So we will take the remaining part. So man, Marcus or not ruler Caesar or try to assassinate Marcus comma Caesar. We will check whether it matches with any of this. Here you can see here we have a when you are comparing with the first one, there is a man Marcus is there, and here we have non-man Marcus. So they are complementary clause, so they will cancel. We will take the remaining thing, that is not ruler Caesar or try to assassinate Marcus comma Caesar. Again, we will check with any of the clause if there is any matching. So here in the fourth one, we have ruler Caesar. So when we are comparing these two, here you can see here it is ruler not ruler Caesar and ruler Caesar are both are complementary clause, so they will cancel. So we have not try to assassinate Marcus comma Caesar. Again, we will check go through the clause. You can see when we are comparing with the eighth one, they are complementary clause. Not assassinate Marcus comma Caesar and try to assassinate Marcus comma Caesar, and we will get an empty clause. So empty clause means since resolving the clauses leads to a contradiction, so that means the negation of the goal is false. So that means whatever our assumption is wrong. So that means whatever we have to prove is correct. So we can conclude that hate Marcus comma Caesar. So hates Marcus comma Caesar is proved. Next example we will see. So here a list of facts are given. John likes all kinds of food. Apple and vegetables are food. Anything anyone eats and not killed is food. Yeah, Anil eats peanut and still alive. Harry eats everything that Anil eats, and we have to prove John likes peanut. So first we have to convert this sentence into WF. First step, we will convert the statement into first order logic. So here we can see that John likes all kinds of food. So for representing all, we are using universal quantifier for all x, food of x. So x is a food means John likes. So like implies likes John comma x. So if x is a food, then John likes x. Then apple and vegetables are food. So here we can put food apple and food vegetable. Then anything anyone eats and not killed is food. So here anything anyone eats. So there are two universal quantifiers for all x and for all y. Then anything is a food and here anything is a food and anyone is a person. So that person eats anything. So he can write eats x comma y. If x is a food and y is a person, that means x, sorry, x is a person and y is a food, then x eats y. So it is given and, so we are putting and symbol. Not killed, so we are putting not killed. So killed that person. So x, not killed x implies that y is a food. Anil eats peanut and still alive. So eats Anil comma peanut and alive Anil. Then Harry eats everything that Anil eats. So Anil eats x means then Harry also eats x. So we are putting for all x, that is for all food. Eats Anil comma x implies that. So if all food Anil eats means Harry also eats x. So eats Harry comma x. And here we have seen that here not killed is used, alive is used. So alive means that is alive means not killed. So kill means not alive. So we are representing it as a fact because here we are using killed and alive. So when we are doing the resolution graph, we have to find the complementary clause. So we are writing additional clause. Not killed implies alive x. So x is not killed means x is alive. And alive of x implies not killed. X is alive means not killed x. So we have added two predicates. Then we have to prove John likes peanut. So next step we have to convert this into closed form. When converting to closed form, so first step is eliminate all the implications. So first one, so we know that if we have P implies Q means it will be converted into not P or Q. So first one, here we can see for all x, food x implies likes John comma x. It will become not P or Q form. Then there is no change in the B. Then C, you can see here. Here we have eat x comma y and not killed x implies food x. So this will become here not P, not of P is eat x comma y and not killed x. Then or Q. Then we are putting or Q. Then next eat al comma peanut and li vanilla. There is no change. And then eat al comma x implies eats Harry comma x. So this will become not P or Q form. Then here also the same thing. Not killed means alive x. So here will become not of P. This is P and it will put not P or Q. Similar to this also same thing. Here we will put not P or Q form. Then we are in the move negation inward. So here we can see there is no change here, no change. Here we can see here the third one, negation is going inside. So negation of eat x comma y and will become, here we have and will become or, and not killed will become killed x. Remaining no change, and remaining all close, there is no change. Next step is rename the variables. That means we have to give a unique variable name and then standardize the variables. So here we can see first case there is only one variable and here in the third case only we are using two variables. So you can see first x we have already used in the first one, and so here in the third one we are giving y and z. And then you can see e here we are giving x y z, and then next we are giving a w, the variable we changed it to w, and f we have changed a new variable name, that is g, and g we are giving k. So the variable names we are giving all variables name as a unique variable name for each clause. And then next is drop universal quantifiers. We are dropping the universal quantifiers in A. Then C we remove. C actually the B we can change into two clause, food apple and food vegetable. So there is an and clause means we can convert this into two clauses. So here you can see food apple is one clause and food vegetable is another clause. Then the C, this we can remove this universal quantifiers. Then D, there is no D also same thing. You can see eat anil comma peanut and alive anil. So if we have and, then we can convert this into two clause. Here you can see E is eats anil comma peanut and F is alive anil. Then next one, here also in the case of E we are removing this all W. Then we can write the remaining thing. Then next F also we are removing, G also we are removing universal quantifiers. So we have removed all the universal quantifiers. Next we are moving to resolution graph. So we are considering the goal. So goal is John likes peanut. So we are taking the negation of goal. That is not likes John comma peanut. Not likes John comma peanut. We are starting from this negation of goal. That is not likes John comma peanut. We are checking whether it is present in any of the clause. So when you go through this, then you can see here we are taking the first one, that is not food of x and not likes not food of x or likes John comma x, and here it is John comma peanut. So if you substitute x as peanut, then these two are complementary clause. So we are substituting x as peanut. So these two complementary clause will cancel, and the remaining thing is not food peanut. So this we will get not food peanut. Then we are comparing with the other clause. Here you can see that here this is not food peanut, and we are searching for food. So here you can see in the case of D, there is a food z is there. So we are considering this one, not eat y comma z or killed y or food z. So if you substitute z as peanut, so if you substitute z as peanut, then the remaining part is not y and not eats y comma z is peanut or killed y. So this food is that food peanut and not food peanut are complementary clause. So then we will check with this. So we will check whether killed or not killed is available. So here you can see or eats or eats y comma peanuts if anything is matches with any of the clause. Here you can see that here we have in the case of eats anil comma eats anil comma peanut is available here in the clause E. So we are considering this one, and here we have not eats y comma peanut. So we can substitute y as anil. So we are substituting y as anil. So these are two complementary clause, eats y comma peanut and eats anil comma peanut. Here y is anil means these are complementary clause. So the remaining thing is killed y is anil, so killed anil. So again we are checking killed and not killed is there. So if you are considering the ith one, you can see not alive k or not killed k. So here we can substitute k as anil. So then it will become killed not killed anil, and killed anil will be complementary clause, and the remaining part is not alive anil. And here in the case of F, there is a alive anil is there. So these are two complementary clause, and the conclusion is empty clause. So empty clause means whatever will be our assumption that is wrong. So not likes peanut, John comma peanut is wrong. So that means John likes peanut. So it is true. This is the explanation of the resolution graph. We have already discussed this. Here we can consider the next example. So here we have a list of facts. Anyone passing his history exam and winning the lottery is happy. Anyone who studies or is lucky can pass all his exams. John did not study, but he is lucky. Anyone who is lucky wins the lottery, and we have to prove John is happy. So first we have to convert this into first order predicate logic. So first one we can see here, anyone passing his history exam and winning the lottery is happy. So we can use the universal quantifier, because for all x he is passing history exam means um, he is passing the history exam and winning the lottery is happy. So we are writing for all x pass x comma history and win x comma lottery implies x is happy. Anyone who studies or is lucky can pass all his exam. So there we have anyone for representing anyone we need all x, and for representing all his exam we need all y. So here we have x is studying, right? So for all x study x, there is or is there, so we will put or, and he is lucky, so x is lucky, so x lucky implies that he can pass. So x can pass all exams, so we are putting y for all y, so pass x comma y. Then John did not study but he is lucky. So John did not study, so it is not study John. And he but he is lucky means, and he is lucky, and so we put and lucky John. Then anyone who is lucky wins the lottery. So for all x who is lucky, for all x lucky x means implies that he wins the lottery, so win x comma lottery. So these are here the facts we have converted into first order predicate logic, WFF. Next we will see. Now we can convert this into a clause form. So we will see how we can convert. So first we have for all x pass x comma history and win x comma lottery gives implies happy of x. So here this is in the form of P implies Q. So how we will convert, our first step is we will convert this into or P, sorry, not P or Q. So here we can convert into not of pass x comma history and win x comma history. So this not is for all part, and then the or happy x. Then that is the first step. Then we can take this invert inside. So this will become not pass x comma history, and this will become or and not win x comma lottery or happy x. Then we can drop this all x. So we will get like this, not pass x comma history or not win x comma lottery or happy x. Next is second one. Here we have study x or lucky x implies pass x comma y. So this is also similar to P gives Q. So here we can convert into not. We can convert not P, and this will become or pass x comma y. And this not we can take invert, then this will be not study x, and this or will become and not lucky x or pass x comma y. Then we can drop this x or for all x and all y. Now it will become in the form of, you can see here, not x and not y or pass x comma y. So now this is in the form of p and q or r. So this is in the form of p and q or r. So this we can write it as p or r as one clause and q or r on the other clause. Q or r is the next clause. So this will become p is not study x. So not study x and r is pass x comma y. So not study x or pass not study x or pass xy. And x we have already used in the previous clause. So we are giving a unique variable name. So here we can write not study y or pass y comma z. Then next is q or r. So q or r means q is not lucky x. So not lucky x or r is pass x comma y. Here also we are giving a unique variable name. So this will become not lucky of w or pass w comma v. Then we can see here next one, third one, not study John and lucky John. This is the and form, p and q form. So p and q we are writing as two separate clause. One is p and another one is q. So here we can write not study John is one clause and lucky John is second clause. Then the last one for all x, lucky x implies win x comma lottery. So this is in the form of p implies q. So this we can write it as not p or q. So this will become not lucky. Instead of x we are using a unique variable name u or win u comma lottery. And here we have to prove that John is happy. So we are taking the negation of the conclusion, that is not happy John. So we are starting from the not happy John. Now we can see the resolution graph of this problem. So here we can start with the first clause. So here we are considering not pass x comma history or not win x comma lottery or happy x. We will see if there is any complementary clause in the remaining clause. So here we can consider the sixth one. So sixth one, you can see there is a win u comma lottery, and in the first clause we have not win x comma lottery. So we can here we can substitute x as u. So then these two are complementary clause, and they will cancel, and so the remaining part is not pass u comma history or happy u or not lucky u. So this will be the resulting clause. Then we will see if there is any complementary clause in this. Here we can see that here we have happy you, and we have in the seventh clause, that is not happy John. So these two are complementary clause. So the remaining part. So if you substitute you as John, so we are applying the unification and we are substituting u as John. So the remaining part is not pass John comma history or not lucky John. So we have these two portion predicates. So here this will become not past John comma history or not lucky you. Again we will check is there any complementary clauses there. So here you can see again we have a lucky John is there. So that is fifth one. So if you compare with the fifth one, then not lucky John and the lucky John, these are complementary clause. So the remaining part is not past John comma history. Then we will see any complementary clauses there. Here in the, if you are considering 2 or 3, there is a complementary clauses there. So I am considering the third one, that is not lucky, past, not lucky, um, uh, not lucky, here it is, not lucky W and pass W comma V. W comma V. So here we can substitute B as sorry, W as John. So we can substitute W as John and V as history. So this will become here we can see that these two are complementary clause and pass W comma V and not pass John comma history. If we substitute W as John and B as history, so the remaining part is not lucky, um, not lucky John will be there and not lucky John. So here in the fifth clause we can see here there is a lucky John is there, so we will get a empty clause. So if you are getting empty clause means, if you are getting the empty clause means there is a our assumption is wrong. So our assumption is not happy John. So this is wrong. So that means John is happy. So we proved John is happy. Thank you.